In this unit, we're going to review Pythagorean theorem and also study its converse to see how we can use that to determine different types of triangles. So if you recall, Pythagorean theorem states that if I have a right triangle like I do here, the two legs are A and B and the hypotenuse is C. So the theorem states that for any triangle, for any right triangle, there's this relationship that's c squared equals a squared plus b squared. It's really important to note that it doesn't matter how you label a and b. They both are legs, but c has to be the hypotenuse, which is the longest side of a right triangle. And as you can see, this theorem gives you the relationship of the three sides of a right triangle. Therefore, we are using it constantly to find the missing side length of a right triangle. Again, it's only applied to right triangles. And A and B, as I said, are called legs, and C is called hypotenuse. There we go. Let's do some practice here. We've got two legs, 8 and 13. So this would be my A, 13 would be my B, and X is my C. If I plug into my C squared plus A squared equals to B squared, I would have the setup of C squared, which is X squared, equals 8 squared plus 13 squared. So you should use your calculator, and your final answer should be approximately 15.3. That's your final answer. Same thing with this example. I can simply do hypotenuse is my x squared equals 27 squared plus 22 squared. And that comes out to be 1213. If I take a square root of that on both sides, I would end up with approximately 34.8. Some more examples. I think what I'm gonna, this one here, the unknown side is one of the legs, so we can name that A. And my hypotenuse is 9, so c squared is 9 squared equals 7 squared plus x squared. And therefore x squared equals 81 minus 49, which comes out to be 32. And if I square root that, and it's approximately 5.7. Excuse me. Okay. Number 4 should be exactly the same approach. I will just tell you the answer here is approximately 23.8. Make sure that you practice on your own. Number 5 is slightly trickier. I don't have a right triangle here. However, these two indicates that this is an equilateral triangle. And if you draw a line right in the middle, if you recall from the previous chapter, if I draw an angle bisector like this dotted line, this angle bisector also happens to be the perpendicular bisector, right? Which means that this is if I call this point M is my midpoint. So I would cut that line at the bottom, in the segment in the bottom, into two exact halves. So in this case, because it's a perpendicular bisector, I do have two right triangles, and X is one of the legs, and the hypotenuse is 24. So the setup should be 24 squared equals one leg, which is 11 squared, plus the other leg squared, which is X squared. If you finish calculating, you should have about 21.3. Okay. Number 6, equally tricky, but see if I can manipulate this graph a little bit. Notice that it's two right angles there. So if I draw a line that parallels, if I draw a line like this, oops, see if I can extend that line a little, parallels to each other, I would have a rectangular shape right here in the green part, right? Which means that this blue line is also x. Now, because I drew a parallel line, this angle would be a right angle because they are corresponding angles. For parallel lines, this is the transverse, so the corresponding angles would be congruent. So now I have a big right triangle on this side, and my hypotenuse is 16. Be very careful. I have here 18 is from front to back, and then this little part, let me change the color. If I use red here, this little part would be 5 because this other side is 5, right? So therefore I have to do a little bit of manipulation to find this length, and this would be 18 minus 5. Oops, 18 minus 5 is 13. So that leg is 13 squared, and then my blue leg is x squared. So again, if you plug it into your calculator, your final answer should be approximately 9.3. And that's your final answer. Let's look at number 7. Notice that it doesn't say, some of you may think that this is a right angle right there. That's not correct. If they don't give you the little mark here, the indicator here, you cannot assume that that's a right angle. And that obviously makes life a lot more challenging, because if I know that's right angle, I have my hypotenuse, I have my two legs already. But because I don't have it, I have to look at other ways. Notice that if I have a right angle here, I've got a green right triangle here, and I've got a yellow right triangle on the right hand side approximately, right? So, and let's look at the green side. In the green side, I know the leg, I know one leg, I know the hypotenuse. I obviously can find this little leg called A. So let's do that. My setup would be 14 squared is the hypotenuse equals A squared plus 12 squared. And A would be approximately 7.2. Now let me change my color to red. In the yellow part, I also have the hypotenuse and I have the leg. So I can find B. So the setup would be 29 squared is the hypotenuse equals A squared, which is 12 squared plus B squared. And my B, excuse me, would come out to be approximately 26.4. So now I can say my X obviously equals A plus B. So my X would equal approximately 33 plus 6. That's the way to solve this. In other words, look for the smaller triangles and then just add them together. Okay? This one, let's see. 2 triangles, I'm asked to find X. My eyes are drawn to the top right triangle. However, out of 3 sides, I need to know 2 sides. I don't have enough information. I don't know the side length of the bottom leg. But if I look at the small triangle, I can find out that my hypotenuse is 25, my one leg is 10, and if I call this, let me call this B, so I can find my other leg. And my other leg is approximately, let's see, my other leg is approximately 22.9. And once I find this, now I can go back to my big triangle where the hypotenuse is 28 squared. My one leg is 22.9 squared, and I need to find the other leg. So that should come out to be about 16.1. And finally, check your answers. If I have B here is approximately 22.9 and X is about 16.1, that looks about right, proportionally speaking, right? Because the X is the smallest side in this big right triangle. Okay, here's some word problems. For word problems, there's no way around it but to graph your problem. Makes life so much easier. So let's see what we can do about this. It says a roofer leaned a 16-foot ladder against a house. So I have a ladder here and I have a house here, or at least the wall of the house here. And it says the base from the ladder is about 5 feet. Let's see if I extend this ladder a little bit. Oops, doesn't work. There we go. So it says that the base here to the foot of the house, this is 5 feet. And the ladder is right here, and that's about 16 feet. Now I have a right triangle right there, and it's asking me how high up, what is the height of the house to the where the ladder touches the house. So that's obviously a very simple setup now, right? Because your hypotenuse is 16. So if you just solve that problem, you should have X is approximately 15.2 feet. There's your answer. Here, Kurt is building a deck that's not a triangle, but it's a rectangle like this. And then it says that it's about 10 by 23 feet. What is the length of the diagonal of the deck? So it wants to know from here to here. What is that length? Okay, obviously when it's a rectangle, it's 90 degrees in the corner. So now you've got 2 legs. You can set it up to solve for the hypotenuse. That's why people who are good at math are really good with home improvement projects. Your X should be, the diagonal should be about 25 feet or so, 25.1 feet. And it doesn't really matter how you set up the rectangle. You can say, you know, you can calculate this diagonal if you want. Because it's a rectangle, everything is congruent. All the corresponding parts are congruent. So whichever direction you set it up, you should arrive at the same answer. I'm not gonna do these 12 and 13. I will leave it to yourself. Okay, finish those and then we can discuss it in class if you have trouble with those. I do want to review the converse of Pythagorean theorem. The converse of Pythagorean theorem. So if you recall, Pythagorean theorem says, if I square the hypotenuse, excuse me, the theorem says, if I have a right triangle, then I would have this relationship. My hypotenuse would equal squared would equal a squared plus b squared. So the converse, we just need to swap the if-then, right? Swap the hypotheses with the conclusion. So I say if my 3 sides happen to have this relationship, if c squared equals a squared plus b squared, then this triangle is a right triangle. And if c squared is less than a squared plus b squared, then I have an acute triangle. And if c squared is greater than a squared plus b squared, then I have an obtuse triangle. Okay, notice here it says always keep c squared on the left to avoid confusion when classifying these triangles. And that's because when we have this, notice that when it's less than, generally when we think about acute triangles, right, we think about the angles being less than 90 degrees. Whereas when we think about obtuse triangle, we think about that big fat angle that's greater than 90 degrees. So that just makes our brain work a little less. It's a trick. Otherwise, it can be confusing. So let's see. We're given the side length 379. We have to determine what kind of triangle it is. But before we do that, we have to first determine whether that is a triangle or not. If you recall, we have that theorem that two sides, if I add the two sides together, 3 plus 7, that sum has to be greater than the third side. Therefore, I have a triangle. And now I can determine what is my c squared and what is my a squared plus b squared. So my c squared, be very careful, c has to be, I like the green better, c has to be the hypotenuse, which is the longest side. So that would be 9 squared, which is 81. A squared is 9, b squared is 49. And if you add it together, I would have 58. 81 is greater than 58. Therefore, c squared is greater than a squared plus b squared. And so now I have an obtuse triangle. Okay, so the second one, same thing. I have to add the two together. I have 41. 41 is greater than my longest side, so I do have a triangle. And now I just need to square the longest side, see if that's bigger or smaller or equal to 20 squared plus 21 squared. As it turned out, on the left-hand side, I have 841. On the right-hand side, I have 841. They equal each other. Therefore, I have a right triangle. Okay? The last example I want to do, this is fairly straightforward. The last example I want to do is this one. I add the two together, I have 15. 15 is less than my third side, therefore I don't have a right triangle. Okay, so continue with the rest of it, but as you can tell, the converse of Pythagorean theorem is really handy when we are using it to determine what of triangles that we have. All right, guys, I will see you in class. Thank you. Bye-bye.